Diablo 2. Even if you never played it, you probably know that it features randomly generated maps that make every playthrough feel different. Arcane Sanctuary is the most famous example. You are dropped in this trippy space dungeon and there's a 4-way crossing. Which path leads to the exit? There's no way to know without checking them all. Or is there? How random are these maps really? Such things in games are rarely actually random, just pseudo-random. There's an RNG that starts with a single number as a seed. If you know that seed, you can predict everything. When playing offline, that seed is generated when you create a new character or change difficulty. On Battle.net, it's generated each game, which is why your maps keep changing when playing online. And it turns out that seed is surprisingly small. Only 31 bits are used. That's just 2 billion distinct maps. Sounds like a lot, but take a walk with me through Act 1. You have all seen the 4 different variants of town. The exit going to the top right here is the rarest layout. Only about 8% of the possible maps look like this. Or in other words, there are only 170 million possible maps that look like this. Is Cold Plains to the left or straight ahead? Left. Only 85 million maps left. The game has a lot of such decisions that are independent of each other. And with a 31-bit seed, you have exhausted them all after only 31 yes-no questions. And directional questions with 4 choices count as 2 questions. One implication is that not all combinations of map features that could exist are actually generated. That's a mostly useless insight. The less obvious implication is that if you can find enough independent patterns, you can play a game of 20 questions. That allows you to find the exact seed that was used to generate a map, and hence you get the whole map from just 20 questions. But how do we turn these questions into a seed? Well, we can just draw all the maps, extract these features, and build a large lookup table. Drawing the map is surprisingly easy. Older versions of the game come with DLL files that you can just load and call the functions to draw the map. I've wired this up as a web app. Here's the map for the seed we were just looking at. The rendering is mostly based on collision data, but I'm also loading all the points of interests and NPCs and so on. I put a link to this in the description, you can play around with it yourself. Next up, render all the maps and extract features. All 2 billion of them. How long could that take? Oh, about 60 days on my machine? Can we improve that? So, what's slow about rendering maps? Rendering time scales linearly with the size of the area plus some static initialization overhead. Some areas also leak memory, which is pretty annoying. But what if we only render a single area? Some of the smallest level in the early game are the tower levels. Rendering all 2 billion maps for a single tower level takes just a few days. That's much better. Can we get enough information out of just one tower level to fully determine the seed? Let's take a look at how levels are generated internally. Each level is made up of individual rooms that are picked from a set of templates. Tower levels consist of 6 to 8 such rooms. This level just consists of corner pieces and corridors. This one also has a T-intersection and a dead end. And there are variants for each piece. For example, these 2 corridors here, they use the same template, but one is wider than the other. Here's another template for the same corridor direction. This one always has a shrine in it. And that's the only room that can have a shrine and tower, by the way. So it's very easy to identify. And I'm sure you are able to identify this room if you encounter it. In total, there are 52 room variants that can be distinguished with a bit of practice. Is that enough? No, not quite, unfortunately. We are getting around 24 bits of information here due to correlations between which rooms can exist and not all rooms showing up within the same frequency. The exit also carries no information whatsoever because it's just the entry rotated by 90 degrees. But many rooms contain so much more information. For example, take a look at this corner room. Check these graves on the floor. Some are opened, some are closed. Here's the same room in a different seat. The graves are in the exact same positions, but different ones are opened now. Each of these just gives us a bit of information for free, and they're enough to make it work on just a single level. So I crunched the numbers and turned this into a 50 gigabyte lookup table. It's basically just a sorted list based on a deterministic exploration order for efficient lookups. Does it work? Oh yes. More than half of all seeds can be uniquely identified just based on this. But there are some patterns that are shared among tens to hundreds of seeds, so we need a few more bits from other places for those. So a few more days of number crunching? We can get 1 more bit for free from the last level. All odd seeds have the top left layouts, all even seeds the top right layout. More than 99% of layouts are now down to 50 candidates. And the remaining bits? We can just brute force them on demand. Rendering 10 to 50 levels takes less than a second. I've also packaged that up as a web app, link is in the description. Let's walk through an example level. I found this recording of a speedrun showing tower. Let's see if we can find the seed from just this video. Level 1 starts towards bottom right, next is top left, and bottom left, and top right. On level 4 we need to identify all the rooms. This is a corner with armor and weapon racks, followed by a narrow corridor. We need to spot the graves here. First one's closed, second one open, and that's a T intersection. The dead rogues here uniquely identify which one, and the grave is closed. Another corner. This one has a door to the bottom left. All 4 graves are open. Down to about 100 candidates. The other direction was a small dead-end room. We can't see the grave, but that's fine, we don't need to get them all. So now we are down to 46 seed candidates, purely based on the rooms we saw on this level. This can now be brute forced based on other map features. The questions about the directions on the previous levels were part of that and have not yet been applied. Running the brute forcer, and we got it. Yep, that's definitely the level we just saw. How about other levels? The previous one was just one long corridor with no intersection, looks right. Levels 2 and 1 had the exit right to the entrance, yep. So we can render all maps now, purely based on information we got from a video of someone running through tower. Final check, which direction is the summoner in? Top left. Did he get it right in the speedrun? Yeah, he got lucky there, but that's selection bias. Of course a world record speedrun involves some luck. So yeah, that works. It's pretty cool, but I'm not 100% happy with it. You usually wouldn't explore the whole level. Tower levels always turn left, so why would you ever take a right turn at an intersection? You also usually wouldn't check out what exactly is inside a room that you can identify as a dead end from the minimap alone. So I could crunch more numbers to ask questions about other easily distinguishable tells in other levels, or find different locations that leak more bits, but for now I'm happy that this proof of concept works. I've had this idea on my mind for at least 10 years now, that I finally got around to build it. And if you watched me for about 10 minutes now, why not leave a like and consider subscribing? I might follow up on this.